Hey everyone, today we are going to see how to reverse a linked list using stack. We already have a method to add elements into the stack, data into the stack, and what we are going to do is we are going to reverse this uh, linked list using a stack. And how do we do this thing? First of all, what is the requirement here? We have a linked list and we add elements over here, and our goal is to reverse this list that we created and then print them out. So we have an original list and then we have a reverted list. How are we going to achieve this? So we're going to use a stack data structure that we have, a stack class, which is a concrete class in Java, and it extends vector class, which is which extends abstract class, and it implements list interface. So as part of the list family, we do not have to go further into it. It provides functions, inbuilt methods that we can use, like push, pop, peek, empty, and search. We are going to use three of them: push, pop, and to check if a stack is empty. We'll get to that part, but before that, why are we choosing stack? It's a perfect way to reverse inputs a data stream. For example, if you can see, we have a data with elements 1, 2, 3, 4. We push all these elements individually and we pop them up, back out. So as stacked is last in, first out, the element that is pushed the first is the last one to pop out. This way, we get the elements in a reverse order, and this is the same principle we're going to use over here to reverse a linked list. Just a little bit of difference that we have from a normal list is linked list is made up of nodes. So they got, each node has its own data, and it also has an address, a reference to the next node. Fortunately, for reversing this list using stack, we do not have to worry about the maintaining the reference. We do not have to worry about making sure that when the list is reversed, we are pointing to the node in the reverse order. So all we have to make sure that our head is at the end and our tail is in the front, and all the pointing operation happens as we add these elements into the stack. Pretty straightforward. So let's do some coding around that. So we have a method called reverse, which takes linked list as an input and linked list as an output. And we know what we are going to do. We are going to use stack to push. We are going to push elements into the stack. And then we are going to pop these elements out of the stack, and they will be popped in a linked list as well. So we know we want to return a reversed list. So we need to create this list. Let's instantiate this at the top. Then we also need a stack to push this elements into the stack. So we have a stack now. Let's give it the generic T so it does not complain about the warning. We don't get the warning. And all we are going to do is we are going to push the node into the stack. Okay. In linked list, always remember we need to keep a track of the head. We do not want to lose head, else nothing will. we can't find anything in the list. So let's grab this head into a current node. Why do we need to grab this into current node? Because our goal is to iterate through the nodes so that we can stack them into so that we can stack them. And in order to iterate, we need to keep a track of each nodes as we go. And that's what we are going to do. We are going to make sure our current node is not null. And we are going to push this current node dot data. Remember, we are not pushing the node itself. Things get a bit complicated. We are only going to push the data inside it. And we need to make sure our current is increased by current dot next. That's how we point to the next node. And let's see what it's complaining about. It requires t. Okay, we have a stack over here. We have define a t over here. Okay, that's good. We have a reverse linked list. Okay, so what's our next thing that we want to do? We want to pop this into reverse list. It's as simple as adding elements into the reverse list that are getting popped from the stack. And this is just like popping one element. We need to again iterate through the stack. How do we do that? We need to make sure we use a while loop and we check to see if the stack is not empty. And that's about it. And here we have implemented a reverse linked list. Let's clear this up and run it again. Okay, this is our original list 4, 10, 24, 5, 44, and this is the list in the reverse order. Very simple. Remember, stack is last in first out. It's a great utility class provided by Java to reverse a linked list. That's all we got. Thanks everyone.